Here are a few problems about piecewise functions. Now, a piecewise function still has an input and it still assigns to every input exactly one output. But what it does is it breaks the input apart. This function says if the input is less than -1, use this equation to calculate the output. If the input is greater than or equal to -1 but less than 3, the output is 4. And if the input is greater than or equal to 3, the output should be 4 divided by the input plus 1. So always one input gets one output. So let's think about that. H of 2, well, you go right to left here. H of 2 doesn't fit in that category, it fits in this category. So I'll say H of 2, I'll follow this rule, H of 2 is 4. Here H of 4, well, it isn't less than -1, it's not in that interval. Here it is bigger than 3, so I'll use this equation. That means it's 4 over 4 plus 1, which is 1 plus 1, which is 2. Now here's an odd case, 2a. Now you happen to know that 2a can be used as an input, but I don't know which category it's in. So what we have to do is we have to put it everywhere. Because I don't know which category it's in, I still have to allow for the different categories. Let's see. It could be 3 times 2a squared if 2a happens to be less than -1. Or it could be 4, notice there's no input there, so I won't change that, if -1 is less than or equal to 2a is less than 3, or it could be 4 over 2a plus 1 if 3 is less than or equal to 2a. Now this can be simplified somewhat. This category, if 2a is less than 1, notice that's the same thing as saying a is less than -1/2. I've just divided both sides by 2. If 2a is between -1 and 3, dividing all three parts by 2 says -1/2 is less than or equal to a is less than or equal to 3/2. Last but not least, dividing both sides by 2, or if 3/2 is less than or equal to a, okay, then I'm going to get these rules. Now remember, by order of operations, this is 2a times 2a, that's 4a squared times 3. 4a squared times 3 is 12a squared. Think about that. This is still a constant 4. This 4 divided by 2a becomes 2 over a plus 1. So take some time to think about that. That's a little bit specialized for piecewise functions, but I think it's important to think about that process. Here's another one to practice. This one has an absolute value and a square root in it. So let's think about that. C, you don't have to have x here. Notice that my domain is described in terms of t's. So I've got these three pieces, c of 10. Now 10 is the t value and it's greater than 2. So I'm going to use this bottom line that says c of 10 is 10. C of 1.5, well 1.5 is between 1 and 2, so I'm going to use the second equation there. That gives me the absolute value of 2 times the square root of 1.5 minus 4. Now here we run into a little bit of a subtle issue. Well, if I knew that this was positive, I could just drop those absolute value signs. And if I knew this was negative, I could drop the absolute value signs and put a negative in front of it with parentheses, right? So the absolute value of -6 is just 6. The question is that positive or negative? That is the question. Well, here your number sense comes into play. Okay, the question is really, is this thing bigger than or equal to 4, or is it less than 4? Well, and if you have 2 times something and you're asking is it bigger than 4, the question really comes down to is the square root of 1.5 greater than or equal to or less than 2. Okay? Now you could actually work that out saying is this greater than or equal to 0, and you could work down to this step. But I'm hoping you follow that. Now I happen to know that this is equal to the square root of 4. So this clearly is less than the square root of 4. So if this is less than 2, this value is going to be smaller in magnitude than that value. That means this thing inside is negative. What's that mean? That means we have negative 1 times the thing inside. That will give me a positive value. Negative times this negative value gives me a positive value. I can now distribute the negative 1. So that's negative 2 root 1.5 plus 4. That will be a positive number, and that is the output of C of 1.5.